Hello everyone. Alright, so today we're going to get started on how to find the domain of a rational function. Okay? So what it entails is that the first thing we have to do is to determine if the denominator is equal to 0, right? So because we know that anything, I'm going to represent a as any number over 0 is undefined. Okay? So if your denominator is equal to 0, then it is undefined. Okay? A lot of people get confused about if x is equal to 0, then it's undefined. No, that's not correct. If the whole expression is equal to 0, then it will be undefined. Okay? The 9 minus x. Okay, so, which means that there is only one value in this case that's going to be equal to 0, right? So if I plug in a value for x, in this case it will be 9, then 9 minus 9 is equal to 0. It's only that value. There's no other values that's going to make this rational function undefined. It does not matter for the numerator. The numerator could be 0, 9, 1 million, negative 1 billion. It does not matter. The numerator does not have an effect or impact on how the rational function is going to be undefined. Okay? So our sole focus should be on the denominator. Okay, so to determine first when this function is undefined, then we have to set 9 minus x equal to 0, right? Solve for x, so negative x equal to negative 9, divide by negative 1, or multiply by negative 1, and then we know that x, right? A negative divided by negative is positive, same thing here, so it's positive 9. So we know that x cannot be equal to 9, right? So 9 minus x cannot be equal to 0. Therefore, x cannot be equal to 9. All right, so now, what is the domain? Well, the domain represents all the value, right? So the domain represent all the values of x that makes the function, in this case, rational function, defined. Okay, so here we have undefined, which means does not exist. And obviously, we have defined, that means exist. Okay, so that's the difference between those two. Okay, so that means any other number besides 9s makes the expression, the function, a defined one, meaning that you're going to have a value that exists. Okay, a divided by 0, it does not exist, it doesn't represent a number. Okay, so how do we find, or how do we express a a domain, right? So let's look at the first way to represent the domain, right? So you have what we call the builder set notation, which is as follows, which means that we have for all x, that's what it means, and then you have like kind of vertical bar here, and x for all x, then we say that x is not equal to 9, and that's it. Usually you only put here right next to the vertical bar whatever x cannot be equal to. Here it means for all x, this means, for all x, and then we say x cannot be equal to 9, right? That's it. That's what it means. So that's called the set builder notation, right? So set builder notation. I don't know if you're gonna use that in Connect Math, but that's the one way of representing the domain. Second one will be the graph notation. And then the graph notation is basically a number line, right? And the number line goes from negative infinity to infinity, correct? Okay. So it represents all the value between negative infinity, all the real numbers, okay? So basically, are we saying here that it's just 9 is not part of the, everything else is part of the domain except 9? How do we represent that? So we're first going to represent 9. Let's say 9 is right here. Okay? And one of the ways that you can represent 9 being excluded from the domain is to put a open circle at 9. And all it means is that 9 is not part of the solution. Okay? And then how do we express the rest? Then you can highlight it with whatever color you want, right? This represents any values beyond 9 and goes to positive infinity. And then here, all the values that are below 9 and goes to negative infinity. From negative infinity to 9, and then from 9 to infinity, and then here, this is being 9 is excluded from domain. Okay? All right. So now, let's look at the third way of doing it. And I think you have to use that for Connect Math. You have to use it in this interval notation. So here we have graph notation, right? Graph form or graph notation. But it's more graph form. And then the last one will be interval notation. For interval notation. Okay? And how do we do that? Then you can kind of use the graph form if you wanted to. Because now so we have to express all the value between negative infinity to 9, right? Excluding 9, and then from 9 to infinity. So this is how you're going to write that out. To express, so it's going to start with an open parenthesis. Okay? And it's going to start at negative infinity. And the reason why we start with an open parenthesis is because negative infinity is not a known number. It is a number, but it can go as far as your imagination can go. Okay? So, negative infinity, 2, and then we're going to put a comma, 9. Okay. You said, well, we say that 9 is excluded. How do I represent 9 being excluded? Then we close the parenthesis. The parenthesis here means that you're excluding, okay, the value before it, okay? So you're excluding that value, okay? If I was not excluding, if I was part of it, then I would put a bracket, okay, if it was part of the solution. But in this case, it is not. So we put a. Alright, so this here represent this part. So first part, this is the representation of negative infinity to 9. That's number 1. Now I have to add the second part. How do I represent that? What kind of notation am I going to use that's going to say, oh, I'm adding another part? We're going to use the union sign. Okay? That's a big U right there. Right? It means that I'm adding another set of, or another interval to this set of intervals. Okay? And then if I'm adding that number 2 here, it goes from 9 to infinity. Okay? And so I'm opening the parentheses to show that 9 is excluded. And then from 9 to infinity. And then close parentheses because infinity is a number that we do not know. Okay? And that's it. And you notice that I started from left to right in my interval notation. This is very important. You cannot write 9 to infinity and then infinity to 9. You cannot do that. This is a 0. Okay? So you cannot do that. Okay? The right way to do it is this way. All right. So now let's move on to the second one. We're going to do something similar to that. All right. So again, we want to find the domain of this. And we never care about the numerator, x squared minus 25. We do not care about it. Okay? The only thing we care about is that the expression here cannot be equal to 0. That's what we care about. So, we have a polynomial here, right? We have a quadratic expression. So, let's factor it and determine what x cannot be equal to. Okay. So here, if I factor this, it would be, let's try to factor it. It would be x times x, and then maybe that's going to be 6 and 9. 6 and 9 is 54, and the sum must be negative 15. So it has to be negative 9 and negative 6, right? So negative 9, negative 6. Okay, so we saw last week how to factor this, so it shouldn't be any surprise here. Okay, so we have x minus 9 times x minus 6, negative 9 plus negative 6 is negative 15, and negative 9 times negative 6 is positive 54. So we're on the right track here. Alright, so now we have to set each factor to not equal to 0, because it cannot be equal to 0. So x minus 9 cannot be equal to 0, or x minus 6 cannot be equal to 0. Okay, which means that x cannot be equal to positive 9, or x cannot be equal to positive 6. Beautiful. Those are the value that makes, so now we have two values that makes the rational expression undefined, meaning that if we plug in 9 and 6, 9 or 6, this old g of x is going to be undefined. Okay, so let's express it. We're going to express it in a graph form and then set interval notation form, right? Because those are the most two important ones. So here we have from negative infinity to infinity. And then I'm going to put those two values. But let's not forget, I need to put them in order, right? From least to greatest. So from left to right, I need to put 6 first and then 9 after, right? So negative infinity, 6, 9, and positive infinity. Now let's express the fact that 6 and 9 are not part of the solution or not part of the domain. So let's put open circle here, open circle there. Okay? And now anything else, so from negative infinity to 6, this is part of my domain. From 6 to 9 is also part of the domain. And then from 9 to infinity, that's also, so I have 3 parts here. So you have 1, 2, and 3. Okay? All right, so let's find the domain in set builder in interval notation. So we start at negative infinity. So open parenthesis, negative infinity to 6. 6 is not part of the domain, so close parenthesis, right? Now I'm adding number 2, so I use the union sign, right? And then I start at 6, is not included, so I put an open parenthesis, and it goes to from 6 to 9, right? But 9 is not included, so 6 to 9, close parenthesis. Then I go, again, there's another set there, I put a union sign and go from 9 to infinity, 9 to infinity, and that's it. Okay, so I have my 3 parts there, right? I have 1, 2, and 3. Okay, that's it. That's your domain. Okay, so that's domain. That's how you represent it. Okay, so we are done with finding the domain of a rational function. All right, so now let's get into simplifying a rational expression. And we're going to do that by through factoring. Okay, so basically all we're doing is, like, if I had 8 over 10, right? If I say simplify this, then I'm really looking at the factors of 8, right? Possibly 4 times 2, right? And I'll do the same thing with 10. Oh, this is 5 times 2, correct? And then I have what? So I factor the top and factor the bottom with the intent to simplify it, meaning I want to find the same common factor on top and at the bottom. So I have a 2 here, right, at the top and 2 at the bottom, and I've simplified, and my final answer is 4 over 5. Okay, that's basically what I want to do here. I'm going to factor the top, I'm going to factor the bottom, and whatever I have in common on top and at the bottom, I'm going to simplify. All right, so let's do that. So on top, I have x squared minus 5x. Okay, so this is not the difference of 2 squared, because 5 is not a perfect square and x is not a perfect square. So what we have to do is find the greatest common factor between those two terms, right? And x is your common factor. So factor out x, and then I'm left with x minus 5. Okay? So that's the top part. Now let's do the bottom part. So it is a trinomial. So we figured that maybe it's going to factor into the product of 2 binomials. So the first term is represented by x and x. And then the factors of 35 where the sum is equal to positive 2. So it seems like that positive 7 times negative 5 is negative 35, and 7 minus 5. So here 7 and negative 5, right? 7 minus 5 is 2, and 7 times negative 5 is negative 35. So it matches, so plus 7 and minus 5. Okay? Now I'm looking at reducing or simplifying this rational expression. I have to have the same factors on top and at the bottom, and x minus 5 is what is in common on top and at the bottom. So I divide them because the fractional bar means division. So x minus 5 divided by x minus 5 is 1 over 1, right? So they cancel out, and I'm left with x, this is what I'm left with, over x plus 7. And that's it. You do not have to, you cannot simplify x and x here. That would be wrong. This is your final answer here, x over x plus 7. Okay? All right. So I don't think you're doing something like this, so that's a higher polynomial. So that was simplifying. All right, so let's do a division, and then we'll get into subtraction and addition. All right, so a division, basically we're going to be doing multiplication and division at the same time. Okay, so the rule for dividing two fractions, right? If you remember, if you have a over b divided by c over d, basically all you're doing is rewriting this as a multiplication, meaning that the first fraction stayed the same, and then you multiply by the reciprocal of c over d, which is d over c, right? So we've seen that in previous weeks, And this is basically turning a division of two fractions into a multiplication of two fractions. All right. All right, so reciprocal. Right? And this goes from division to multiplication. Okay, so let's do exactly that. So we have two rational expression, which is the same thing as fraction, right? And we want to turn this into multiplication. So I'm going to rewrite this the same way, just like it says here, right? So I'm going to rewrite this as x squared, x squared plus 4x plus 4 over x squared plus 9x plus 14 times the reciprocal of x squared plus 2x over x squared plus 12x plus 35. And that would be x squared plus 12x plus 35 on top, and x squared plus 2x at the bottom. Okay, so now I've changed this into a multiplication. Now I can proceed and do the next step. The next step is just to factor all those trinomials or binomials and then look to simplify. Okay? All right, so here the first one, it will be, let me go down. We have x and x for x squared. Sum of 4, where the sum is 4. It's 2 and 2, right? So plus 2. Plus 2. Beautiful. The bottom one, again, trinomial. And we have x and x, right? And then sum of product of the 14 where the sum is 9. So you have 7 and 2. So plus 7 plus 2. All right, so let's move on to the third one here. The third trinomial, we're going to have x and x. And then sum of, factors of 35 where the sum is 12. Seems like 7 and 5, it should be the combination. 7 times 5, 35. And 7 plus 5, 12. Okay, now, x squared plus 2x, it is not a trinomial. We only have two terms. So we need to find the greatest common factor, which is x. And then it's going to be x times x plus 2. Okay, now we can simplify. Okay, so here I have 1x plus 2 at the bottom, and on top, right here, 1, 1. They cancel each other out, right? Then I have x plus 2 here on top, and also at the bottom here, right? I can simplify these two, right? So it's 1 over 1. And then 1 over 1. Okay? Then let's see if we have another set that can be canceled out. Yeah, we have an x plus 7 on top here and an x plus 7 at the bottom here. Okay. So what do we have left? Is there anything that we can simplify? Nothing else. Here we have x plus 5 and then x. They're not the same. So we will write them on the next line as x plus 5 over x. Okay? That's it. You leave it like this. You don't have to simplify. It will be too complex, but this is it. Okay? So that took care of division and multiplication at the same time. Okay? So I don't need to do this because I just demonstrated that. Let's do some adding and subtracting. I'm going to do the one that we skipped earlier, this one here. All right, so whether we add or subtract fractions, right? Like, for example, if we have, if we have a 2 over 5 plus 3 over 5, if you have the same denominator, you put it as a common denominator, as a single common denominator, which is 5, and then you just add the numerator, 2 plus 3. And then you get 5 over 5, which in turn is equal to 1, right? Okay, but the idea is that if you have the same denominator for the two fractional expression, then you put it as a single denominator, and then you add or subtract the top. Okay? And that's exactly what we're going to do here. We have 9x squared and 9x squared, so we can rewrite this as 14 minus 12 over that single common denominator of 9x squared. Okay? 14 minus 2 is 14 minus 12 is 2, and that's 2 over 9x squared. Okay? One thing that you cannot do is, for example, if you have 2 over 7 minus 3 over 5, is do 2 minus 3, negative 1, and then 7 minus 5 is 2. That's a no. Understood? No. If you have different denominators, then you have to find a common denominator and proceed with that common denominator. But we do not have that in that case. Okay, so let's move on. All right, so let's do this one, because it's kind of treacherous. We're gonna do the next two. Just by looking at it, it looks like it could be the same or it could be totally different. Just by looking at it, it should be different, right? Because here we have x minus 8 and 8 minus x. Not the same thing. However, if we do something, meaning that if you factor out something out of those two expressions, in one of those two expressions, then we can make those denominators the same. Okay? But something needs to be verified first. In order to factor out negative 1, for example, that's the value that we want to do, something must happen. From those two expressions, the first term and last term must be opposite, meaning that here we have positive x, and then here we have negative x. They are opposite. And then here we have negative 8, and then here we have positive 8. They are opposite. If that happens, then I can factor out the negative 1 out of any of those two, and then I will get my common denominator. Let's go and see in practice. So here I have 5 minus x, right, over x minus 8. I'm just going to leave this one as x minus 8. Minus 2x minus 1. And then I'm going to factor out negative 1, right? And then it's going to be, if I factor out negative 1 from 8 is negative 8. If I factor out negative 1 from negative x is positive x. And then next, so here I have negative 8, which is the same thing as this one here, negative 8, and positive x, same thing as this. But I'm just going to rewrite this, kind of use the, what we call the commutative property, right? And we write the next line as 5 minus x, 5 minus x over x minus 8 minus, so here we have to be a little bit smart here, because that negative really makes the whole expression negative. So that negative here, that negative 1 makes this whole rational expression negative. So I'm going to put negative, and I'm going to put the negative right in front of the fractional bar to show that, 2x minus 1. And then here I put negative 8x plus x as x minus 8. So basically here I have a double negative that's going to change it into what? A positive, right? So here, when I rewrite it, I should get 5 minus x over x minus 8 plus 2x minus 1 over x minus 8. Okay? Alright, so now we can put this as a single denominator, single common denominator, and that's going to be 5 minus x plus 2x minus 1 over x minus 8. Okay? So now let's combine the like terms, right? So the 5 with the negative 1, that's 4. That's 4, right? And then the negative x plus 2x is x, or positive x. So it's going to be x plus 4 over x minus 8. That should be my final answer. Okay? So make sure you kind of study this one, because you might get, just kind of go through it again and see if you can understand. And I think you may have some problems like that on your quiz. All right, so let's move on. All right, so I don't need to do this because it has the same denominator. All you have to do is add the numerator. All right, so I'm going to let you do that. Let's move on. I just want to have time to do some different type of problems. All right, so now we have addition of two fractions, but now we have different denominators. So I cannot just add these two, right? So we talked about that. So what we have to do is find what we call the least common denominator. Right, so first find the LCD of y squared minus 3y, y squared minus 3y plus 2, and y squared minus 1. Alright, in order for me to find the LCD, I need to factor this, right? I need to put it in factored form. So this one should be y and y, and then negative 1 and negative 2, right? So negative 1 times negative 2 is positive 2, and negative 1 plus negative 2 is negative 3. So it matches. Y squared minus 1 is the difference of two squares, so it should be y plus 1 times y minus 1. Okay. So, first, if you want to find the LCD of these two here, sets of factors, then the first thing you have to do is say, okay, what is the common factor between those two? And I can see that y minus 1 is the common factor, right? So that's going to be part of my LCD, y minus 1, right? So that's what is in common. So I'm putting parentheses here, okay? And what is part of the LC is whatever is left, which is the y minus 2 and the y plus 1. And let me try to put it right. So what is? Give me a second. I thought. Not bad. All right. So, to recap real quick, to find the LCD, you look at whatever is in common, the y minus 1 from the factors, and then whatever is left, the y minus 2 and the y plus 1, right? So that's what we have here, right? And then that's your LCD. Now, so this is basically 2 over y minus 1, y minus 2, plus 7 over y plus 1 times y minus 1. All right, so here's a quick, this is a shortcut that I have. So now we know that the LCD is this. So here, all I have to do for my first expression here, 2 over y minus 1, y minus 2, I can just include whatever is the missing factors here, which is y plus 1, right? From the LCD, right? That's my LCD. But not only I have to include it at the bottom, but also I have to include it on top, right? Okay, so now I have my equivalent expression. So the next term, I have y plus 1 and y minus 1. What's missing? The y minus 2. So I put y minus 2, I include y minus 2. And then here, include y minus 2. Okay, so that's a kind of a shortcut. And so now, moving on. So now I have the least common denominator. Let's put it as a single common denominator. So the top is going to be 2 times y plus 1 plus 7 times y minus 2 over that single common denominator of y minus 1, y minus 2, y plus 1. Okay? All right. Now we need to simplify the top and see if we can combine and maybe factor. So we get, oh, hey, how you doing?
Okay.
You got some Häagen-Dazs? How you doing?
Good.
Where you at?
Huh?
Where you at?
Sheena's house.
I know.
You know what? You know what I mean.
Hey.
Chocolate. Dad said hey. Hey. How you doing?
I'm good.
Yeah, he can see you.
Hey. How you doing?
He said, how you doing? Good.
Yeah, I can see that. That's cool.
It's too far. Hey.
Oh, wow. He already changed.
He's already big. He's fat.
Yeah, he's fat now, for sure.
Yeah, he's gaining weight.
That's good. That's good.
Yeah.
How you doing?
Good, good. Can I see him? Want to pause it? Ah, there you are. Hey, how are you?
I'm good, and you?
Good, good to see you.
Nice.
We're good. And now he's sleeping over.
Yeah, I know.
Yeah, Jaleel couldn't because he said he got some allergy shots today. So he couldn't with the dog and the cat. He said it was too much for him.
Yeah,
So
I know.
yeah, it's only gonna be a night.
Okay, that's good, that's good. The baby is big now. Like, damn.
He's big, man. Yeah, I went to the pediatrician and they said that he gained a lot of weight.
So,
That he
okay.
gained a lot of weight. So I can't wait for you to meet him in person. It's gonna be nice.
Yeah,
He's so
I'm planning on coming. I'm planning on coming soon. So,
okay. Well, let us know. Let us know. Are you gonna fly or are you gonna drive?
hey, what happened to your teeth? Like, they straightened up? Let me see.
Ah, you didn't notice?
Oh, now okay. Cool. I'm like. No, cause it was like straight up. I'm like, this is.
Wait, hold on. Where's the volume? Can it go higher now? Oh, okay. It's not an iPhone, so you know.
Oh.
I'm playing. No, I was asking, are you gonna fly or are you gonna drive?
No, I'm gonna fly. It's too far.
Okay. Well, yeah, let us know, and that way we can pick you up from the airport.
Yeah, that's fine. That's fine. I think I might come at the end of the month, or sometimes in October, just for like a week, maybe less. I don't know. We'll see.
Oh, okay, sounds good then. We
Yeah,
can
yeah,
see you.
yeah. Tell her, huh?
No, I said we can't wait to see you.
All right, yeah. I can't wait to see the baby and everybody else.
Yeah.
Okay.
Want to talk to your daddy? Yeah? You want to play for him? Yeah? No, I think that you're going to have to say hi to him. That's all I
What? Damn, like. Ça va? Oh, yeah. That's good. That's good. That's good. Yeah. I'm good. I'm good. I have my office. I changed it a little bit. You know. Yeah. Let me show you.
I see Bob Marley in the back.
Yeah. But I have.
Ooh, look at that.
Yeah. I got.
Wow. That's nice.
Yeah. So I got my. Mon matos quoi.
Ah ouais. C'est beaucoup travailler quoi.
Yeah. So I got.
Show it again.
What, his office?
Yeah. Look
Oh,
at that.
nice. Did you lose him? I think you paused it. Or maybe, no, he paused it. Oh, wow. Wait, you had 3 screens?
Yeah. Well, 2 screens and then my laptop. Hold on. So
Oh, wow.
I got my little vertical. So yeah, I got my little office. You know.
Nice. I like it.
Yeah. So
Yeah, no, it's so nice. That's a lot of screens, man.
yeah. Because I have to program and I have to do the work for the schools and stuff. So, but yeah, it works out. All right. So now let's simplify. Right. So we have the 2 times y plus 2 times 1. So that's 2y plus 2 plus 7 times y times 7 times negative 2. That's 14y minus 14. Oh, sorry. Mistake here. 7y minus 14. Okay? Everything over y minus 1, y minus 2, and y plus 1. Okay? Let's combine like terms. 2y plus 7y is 9y. And plus 2 minus 14 is negative 12. So it's negative 12. Over, again, y minus 1, y minus 2, y plus 1. Okay? And that's it. I mean, you could factor 9y minus 12 if you wanted to, but it's not going to go further. It's just going to be, you can write it as this, and then you factor out the 3 and get 3y minus 4 over y minus 1, y plus y minus 2, and then y plus 1. Okay? Nothing's going to happen here. Nothing's going to simplify itself. So you can leave it as this if you want, or you can use this. All right. So now let's get to, complex fraction. Let me do this complex fraction and then this one. And we will do, and then if you have any questions, because otherwise I'm going to go beyond the hour, just send me an email with the exercise that you're struggling with. Okay? All right. All right, so let's do this one here. It's a little bit easier, and then we'll do the other one. All right, so here we have what we call the complex fraction, right? It's basically when you have one rational expression over another one, right? So basically if you have A over B, right? That's one expression over another rational expression C over D, Okay? Well, the way it looks, it might be confusing. You're like, oh, wow, what do I do with this? But it's very simple, actually, because we've done it before. It's actually a rational expression, one of them, divided by another rational expression, right? So if I were to rewrite this, I will have a over b divided by c over d. We've seen that, right? Division of two fractions. So all I have to do is rewrite this as a multiplication. We know how to do that. So that's a over b times the reciprocal, right? Which is d over c. And that's it. So my goal is to rewrite that complex fraction, which is in this format, into a multiplication. Okay, so let's do that. So here, this a over b here is going to stay the same. So it's going to be x squared plus 13x plus 42 over x squared plus 14x plus 49 times, right, the reciprocal of this here, which is x squared plus 11x plus 28 over x squared plus 6x. Okay, so we've done an example like that earlier. All we have to do is factor everything, and we get, for the first one, x times x. Factors of 42 where the sum is 13, 6 and 7, so plus 6 plus 7. The bottom one will be x plus 7 times x plus 7, right? 7 plus 7 is 14. 7 times 7, 49. Then the one on top here, we're going to x and x. And then for 7 times 4 is 28. 7 plus 4 is 11. So plus 7 plus 4. Okay, and the bottom one, it's only two terms. So factor out the x, and then you have x times x plus 6. And then let's simplify, right? So here we have x plus 7 over x plus 7. So we can cancel that out, right? We have another x plus 7 on top at the bottom, x plus 7 over x plus 7. We have x plus 6 on top at the bottom, x plus 6 over x plus 6. And that's it. Whatever is left is x plus 4 over x. Okay? Alright, so that's it for this one. So let's move on to this one here. So this one is a little bit different, because now we do not have the scenario that we had earlier, which is a over b over c over d, right? We do not have that here, because this is only one expression. Here we have, well, this is only one term, which is o over b. Here we have two terms, okay? So this is not one term over another term. So here we have 1, 2, 3, 4 terms. So it doesn't fall into that category. So what is the approach? Well, the approach for this one is to first find the LCD of all denominators. Top and bottom. Denominators. Okay. And what are those? It's the x, the 8x, the 7x, and the x. So what is the LCD of all those? The LCD is basically, well, the x term is, the x variable is part of the LCD, so x. And then we have the 7 and 8. They are not, there's nothing in common between those two, so it's 8 times 7, 56. So 56x is your denominator. The least common denominator. So what do I do in this case? Second step, multiply all terms by LCD. How many terms do I have? I have 1, 2, 3, and 4. Those are my LCD. I'm going to multiply all 4 by the LCD. Okay, so let me rewrite this, and then I'm just going to put in the format where. So I'm just rewriting it here so it's a little bit clearer. 3 over 7x minus 1 over x. All right, so multiply all the terms by the LCD. So that means you have 56x here, 56x, and 56x, and 56x. Beautiful. Now, what do? Clear out the fraction, right? So you clear out the fractions, meaning I want to get rid of the denominator. That's what I want to do. How do I do that? I use the LCD, or whatever I multiply all the terms by, the 56x, and divide it by x, or whatever is that denominator. So here, this x over x cancel out. Here, 56 divided by 8 is 7. The x cancel out. Here, 56 divided by 7 is 8. Again, the x cancel out. Here, 56 stays, and the x cancel out. So I've cleared out the fraction, or got rid of all the denominators. So what do I have left? I have the 56 times 3, right? So 18, 168 minus 5 times 7, 35. That's what I have on top. So here I have 8 times 3, 24, minus 1 times 56, 56. Okay? So what do I get here? I get 133. Seems like. Yep. 133 over negative 32. And that's it. That's what simplifying this mean. It will be equal to negative 133 over 32. Okay? All right. All right, so let's move on. Now we can do a problem where, well, we're not doing synthetic division. We're going to do one equation. Yeah. So let's do one. Let's put the next 7 minutes. Yeah. Let's do this one. All right. So we have 23. Number 23, I'm sorry. That's what I meant to say. Oops. I'm so sorry. Okay. Now, all right, so here we have to solve for x. Okay. All right, so for when we're solving a rational equation, there are many, many steps that you have to take into account. First, you have to determine what makes x, what value of x makes the rational, any of those rational expression undefined. That's number one. And then from there, so that's the first step, right? Determine the values of x that make a function, makes rational equation undefined. All right, so we've seen that. So in order to do that, we need to factor some stuff. So here I get 4x times x plus 3, which is the same thing as these two here. So we know that 4x cannot be equal to 0, meaning that x cannot be equal to 0, right? So that's one value. So x cannot be equal to 0. Also, x plus 3 cannot be equal to 0. Therefore, x cannot be equal to -3. And since those factors are the same as the other two, so those are the two values, right? So that's number one. We determine the value that makes the rational equation undefined, right? So we have that. Beautiful. Now, second, find the LCD. And it's kind of easy here because it's 4x and x plus 3 are, this is what we have in common. So 4x times x plus 3 is your LCD. Okay? Third, multiply all terms by LCD, which is a 4x times x plus 3. All right, so let me demonstrate. So let me rewrite the equation, right? And it's going to be 5 over x plus 3 minus, here, give it some space, 1 over 4x equal to, give it some space, 3 over, I'm going to put the 4x squared plus 12x in factored form. I'm going to put the 4x times x plus 3. And then now I'm going to multiply all the terms by LCDs. So we have the 3 terms here. So we have 4x times x plus 3. 4x times x plus 3. And 4 times 4x times x plus 3. Okay. Third or fourth, clear out the fraction. Or clear out the fractions, meaning I want to get rid of these denominators. Okay. All right, so let's do that. So here, what do we have in common on top and the bottom? We have the x plus 3 over the x plus 3, right? So we are left with 4x here. Then here, the second term, we have 4x over 4x. We're left with x plus 3 here. And then here, everything goes the 4x and the 4x and the x plus 3 over the x plus 3. Okay? So that's exactly what we want. We want to clear out the fraction, meaning we want to clear out the denominators. What's next? Well, now we need to multiply. So you have the 4x times the 5. That's 20x minus the x plus 3. X plus 3. And then equal to 3. Beautiful. Now I'm left with 20x. So the negative here, I have to distribute and I get negative x. And then negative times the positive 3 is negative 3. Equal to 3. So I get the 20x minus x, which is 19x, equal to the negative 3 becomes positive 3. So 3 plus 3, 6. And then divide by 19 here. And I get x equal to 6 over 19. Okay, so especially with a rational expression, you have to make sure that this value here does not match any of those two values here. Okay? And it doesn't in this case. So Because it doesn't, then you can say now that the solution is curly brackets 6/19. Okay, so that's one of the things. When you find what the x value is, you need to come back to the original, the start, where you determine what x cannot be equal to make sure that these two they're not equal to. And so that's it. Okay, so that's it for today. If you have any additional question, make sure you email me. I'll be looking at my email tomorrow and answering any question you may have. All right, bye.